Welcome to the unit on Basics of Apparel Production Process. This unit introduces the various departments in garment industry. It also covers the various processes and procedures involved in apparel manufacturing industry. This unit comprises of 3 modules and a final review sections that invites you to reflect on what you have learned. By the end of this unit, student will able to understand the functions of different departments in garment industry, describe the manufacturing process, identify the various equipment used in the garment industry. The first module gives an overview of various departments in the garment industry. Apparel production, also known as garment production, is the process of converting fabric into garment. The term apparel production is usually used when garments are manufactured in factory. Traditionally, apparel manufacturing factory have been divided into 2 segments, domestic and export. Based on present apparel industry, garment manufacturing processes are categorized as pre-production process, production processes and post-production processes. The pre-production process includes sampling, sourcing of raw materials, approvals and production process meeting. The production process includes cutting and sewing. The post-production process includes thread trimming, pressing, checking, folding, packing and shipping inspection. Let us begin with learning about the pre-production process. A factory produces bulk quantity of garments for a style or design at a time. Prior to the start of the production of an order, the factory needs to go through some activities known as pre-production. The pre-production process includes sampling, merchandising, sourcing of raw material and production planning. Sampling is a process where the factory develops garment samples according to the buyer's specification and design. It is also known as product development stage. Samples are required at various stages to get approval from a buyer on a particular design. As per the development stages, samples have been termed as proto sample, fit sample, size set sample, sales room sample, production sample, TOP, that is top of production sample, and shipment sample. Test fitting of a garment is part of the pre-production process. This video shows a garment being test fitted. A business of all about making profit. So, correct costing of a product before finalizing of an order is very important. Costing of a garment is the cumulative cost of raw materials, direct labor, direct and indirect overheads. After developing samples or directly receiving a buyer sample, the factory needs to send freight on board or free on board, that is also known as FOB price of the garment. To decide the FOB of garment, the factory makes a cost sheet including raw material cost, total direct labor, cost of each process and factory overheads. After receiving the order, the factory plans for the requirement of raw material. Raw materials includes fabric, sewing thread, packing material, hang tags and other accessories. The factory plans timelines including when to start cutting, when to submit pre-production sample, when to finish sewing and finishing, the final inspection date and shipment date. In the production planning stage, the job responsibility for different processes are defined. Now let us look at the production process. The production process are basically divided into fabric cutting, printing, embroidery, sewing, thread trimming, washing, ironing, folding and packing. We will also learn about each of these processes. In this stage, fabrics are layered on a table, layered by layer up to the certain height. Then using a cutting machine, the fabric is cut into garment shapes and pattern and separated from the layer. Fabric layering is possible both by manual spreading and automatic spreading. Cut parts are then numbered, bundled and sent to sewing room. Cutting can help save fabric as well as add value to the garment. The quality of the end product, the garment, depends first on good cutting, secondly the main raw material of the garment represents about 70% of the total cost of the garment. That is why cutting is an important process. These videos show a garment being cut. Garment panels are stitched together by sewing machines in the sewing room. In sewing, 2D fabric patterns are converted into 3D form. The operator runs the machine, uses sewing thread to join garment parts together. Various types of the sewing machines are available for sewing. These machines are selected according to the seam and stitch requirement. In apparel industry, traditionally sewing machines are laid in a row. Cut parts are fed at the start of the line, pass through the line, and at the end of the line, a complete garment comes out. Each machine is run by individual operator, and operator sews only one or two operations of the garment. A line consists of sewing operators and helpers to feed them with cut parts, thread and other trims. A quality checker and a fully or partially devoted supervisors. After stitching, all hanging threads are cut with a hand trimmer. This can also be done using automatic thread trimming machine. All loose threads inside a garment are also removed. Garments without any loose thread and a long tail are basically quality requirements. Washing is done when a buyer wants washing or special finishes to the garment. For a light color garments, washing is carried out to remove dirts and stains. Generally, this process includes checking of the garment, measurement checking, ironing and spotting. After sewing of the garments, all pieces are checked by the quality checker to ensure that garments have been made as per buyer quality standards. Checking is normally done by visual appearance and measurements. Spotting is required to remove stains in the pieces. Special chemicals, that is solvents, are used to remove various kinds of oil stains, marks and hard stains. Finally, each garment is ironed with a press to remove creases. Each pressed garment is now folded with tissues or cardboard. Folding varies from product to product and also from buyer to buyer. Hang tags, special tags and price tickets are attached with plastic gimbal or threads. Folded and tagged garments are then packed into poly bags. During packing, garments are randomly checked for internal quality controllers to ensure that only quality goods are being packed. In current fashion trends, very few garments are made without additional processes such as printing, garment dyeing and special washing. Other value-added process includes embroidery, adda work, hand embroidery with lots of beadwork. Once the garment are packed, also known as shipment, quality inspection of the garment is carried out with buyer's quality inspection label, that is also known as EQL label, before it has to be dispatched. A third-party quality auditor may also be hired to do this final inspection. If the packed goods meet the buyer's quality standard, the shipment is accepted by the buyer. The factory then dispatches the goods to the buyer. The second module introduces the process of cutting, sewing and finishing. Departments such as cutting, sewing and finishing are the primary departments of a garment factory. The name of the department itself explains its main functions. Within each department, there are a number of steps through which raw materials are passed to make a finished and packed garment. These steps are sub-processes may vary from product to product. The main role of a cutting department is to cut garment components from fabric roll or fabric as per style specification. The cut components are then sent to sewing department in a bundle. A cutting department of a garment manufacturing unit includes the following sub-processes: fabric relaxation, fabric spreading and layering on the cutting table, marker making. Cutting, these are three types: manual cutting using scissors, machine cutting and automatic cutting. Numbering of garment plies, sorting of and bundling, inspection of cut components, sorting of printing and embroidery panels, recutting of panels, fusing garment components. The sewing department is heart of manufacturing unit. Cut components are assembled in sewing department in a assembly process. The list of sub-activities that are done in sewing department includes making garment parts, sewing the full garment, making garment accessories such as dori, tab, cords, checking of stitched garments, alteration work of defective garments. The objective of sewing are the construction of seams which combine the required standard of appearance and performance with an appropriate level of economy in production. Assuming that the fabric is sewable and suitable for garment, the achievement at the economical level of various requirements of appearance and performance of sewn seams both initially and during use is the result of the selection of 5 factors during manufacturing. These factors are seam type, the stitch type, the sewing machine fitting mechanism which moves the fabric and enable a succession of stitches to be formed, the needle which inserts the thread into fabric, the thread which forms the stitch which either holds the fabric together, neaten it or decorate it. Those factors are closely interrelated to each other and will be discussed in this course with a view of understand the sewing process in detail. A stitch, which is elementary basis of sewing, can be formed without fabric, within fabric or through or on fabric. For the purpose of standardization of stitches and seam formation, the US government developed a guide that defines stitches and seams in current use. This guide is known as United States Federal Stitches and Seams Specifications, that is Federal Standard 751A. Federal Standard 751A makes the following distinctions by defining these terms. A seam is a joint consisting of a sequence of stitches uniting two or more pieces of material or materials and is used for assembling parts in the production of sewn items. A stitch is one unit of conformation of thread inserting from repeatedly passing a strand or strands and or loop or loops of thread into or through a material at uniformly spaced intervals to form a series of stitches. A stitching consists of a sequence of stitches for finishing an edge or for ornamental purposes or both in preparing parts for assembling. Seams are formed by sewing two or more plies of fabrics together. However, the basis of seam classification is the position of pieces relative to each other. Many variations in fabric position and treatment account for the many different types of seams in each classification. The choice of seam types is determined by aesthetic standards, strength, durability, comfort in wear and convenience in assembly in relation to the machinery available and cost. Certain machine types are more appropriate for some products and fabric than others. Seam length and the degree of curvature of a seam are also important in choosing seam types. The best seam type is one that yields the desired performance at the lowest cost. A seam has 3 dimensions: length, width and depth. Seam length is total distance covered by a continuous series of stitches such as side seam or shoulder seam. Seam width considerations are width of a seam allowances, the seam heading of a lapped or a top stitched seam and a width of a line of stitches relative to the seam. A seam allowance is measured from the cut edge of the fabric to the main line of stitches. Seam depth is the thickness or compressibility or that is flatness of a seam. The Federal Standard 751A, which is basis of stitch classes, identifies 4 seam classes and 2 stitches classes. They are superimposed seam, lap seam, bound seam and flat seam. Each class includes many seam types. The superimposed seam class is formed by joining two or more pieces of fabrics, usually with the seam allowance edges even and on piece superimposed over the second. These can be sewn with a lock stitch, chain stitch, over edge machine or safety stitch. The lapped seam class is defined as two or more pieces of fabric joined by overlapping of the needle. This is largest seam types including 101 different seam types with a great deal of variety as to where a seam is lapped and how it is lapped. These seams are used to attach the front band to shirts, setting pockets, side seams of quality dress shirt, side seam and inseam of jeans, and so on. Lapped seam may be stitched with a lock stitch or a chain stitch, but not an overedge stitch. The bound seam class requires a separate piece of fabric that encompasses the edge of one or more pieces of the garment. These seams are used to finish plain neckline, edges of short sleeves on some style of t-shirts, and so on. The bound seam may be sewn with a lock stitch, chain stitch, or cover stitch. They should never be sewn with edge stitch as a knife will cut off the binding. The flat seam class is the smallest class with only 6 different types. The formation of this seam occurs with the butting together of two pieces of fabric, not overlapping them. The stitches extends across the seam, holding both pieces together and covering the seam on one or both sides. Flat seams are constructed to remain flat through care and wear. The two stitches classes are ornamental stitching and edge finishing. The finishing of either of these classes are performed on a single piece of fabric. The fabric may be folded in a variety of ways. This ensures that the stitching is through more than one thickness but still remain a single piece of the fabric. Ornamental stitching, it may be used on a single ply for decorative purposes. It can be done anywhere on the garment except the edge. The decoration stitches may be used on jeans pockets, embroidered logos, and pin tucks. Here are some examples of ornamental stitching. Edge finishing is stitching that encompasses the cut edge or provides a finish for a single ply of fabric with a folded edge configuration. Stitches from any of the classes may be used depending on the type of fold and placement of stitching. Stitches are classified on the basis of the structure of the stitch and method of formation. Stitch properties such as size, balance, consistency determines stitch quality, performance, and appropriateness of and use. Properties of a stitch that relates to aesthetics and performance are size, tension, and consistency. Stitches are classified based on structure of the stitch, method of formation. Stitch size are 3 dimensions: length, width, and depth. Stitch length is specified as the number of stitches per inch, that is also known as SPI, and can be an indicator of quality. Stitch length is determined by the amount of the fabric that is advanced under needle between penetration. High SPI means short stitches, while low SPI means long stitches. Long stitches are usually less durable and are considered low quality as they are subjected to more abrasion and are likely to snag. Stitch width refers to the horizontal span that is bite covered in the formation of one stitch or single line of stitches. Stitches that have width dimensions require multiple needles or lateral movement of thread carriers such as needle bars, loopers, or spreaders. Stitch depth is distance between the upper and lower surface of the stitch. For example, the depth of the blind stitch determines the amount of penetration of a curved needle. Thread tensions affect stitch formation in two ways. Thread tensions involves the balance of force on the threads that form the stitch and the degree of compression on the fabric created by the threads as a stitch is formed. Tension includes a uniform supply of thread and determines how well stitches conform to the standard formation. Too much tension causes the seam to pucker and can cause uneven stitches, unbalanced stitches, weakened stitches and damaged fabric. Too little tension might result in loose or skipped stitches, greening or weak seams. Stitch consistency is the uniformity with which each stitch is formed in a row of stitches. Each stitches should be exactly like the previous one regardless of curves, corners or varying thickness of the fabric. A stitch can be defined as one unit of conformation resulting from one or more strands or loop of the thread, intralooping, interlooping or passing through material. The 6 classes of stitches are given in Federal Standard 751A are class 100, that is chain stitches, class 200 stitches originating as hand stitches, class 300 as lock stitches, class 400 as multi-thread chain stitches, class 500 as overedge stitches, and final is class 600, that is also known as covering chain stitches. We will now look at each of these in detail. The chain stitch class, that is 100, includes stitch types 101, 102, 103, 104 and 105. It is formed with one or more needle threads that form a loop on the underside of the fabric. It has no lower thread. Type 101 is one of the simplest of all stitches, formed from single thread. It can be easily removed and it is used for basting operations in tailored men's wear and women's wear. It can only be used where the marks of needle penetration close up afterwards in pressing. A basting operation is a temporary stitch allowing accurate placement of permanent stitches. It is used to positions such as edges, flaps and collars. The blind stitch version 103 utilizes a curved needle in order to successively penetrate partially into the fabric and then into the hem edges, while showing minimally or not at all on the right side of the garment. Class 200 stitches consist of hand formation of stitches done by hand with the exception of 205, which simulates a hand running stitches but is formed by a special machine. Typical stitches of class 200 stitches are basting stitches and back stitches. The lock stitch class, that is 300, is the most commonly used and is easiest to understand. A lock stitch machine requires two threads to form a stitch, a needle thread that feeds from top and a lower thread that feeds from a bobbin. The rotary hook or shuttle catches the needle thread loop as it passes around the bobbin and interlocks the two threads. If a lock stitch machine breaks, the two threads used to form the stitch lock and whole line of stitches won't be unravel. Lock stitch machines are versatile and can be used for a variety of the operations. It is also the only stitch formation that can be back stitched. A lock stitch machine is a good choice for a small manufacturer that produces fashion goods. A complete Garment can be sewn on a lock stitch machine. Also, if versatility is needed, a lock stitch is a good choice, but if speed and efficiency are priority, it may not be the right selection. Lock stitch machines are slower than other classes of industrial machines. Operating speeds of these machines ranges from 3000 to 5000 revolutions per minute, that is RPM, while other machines can operate at 9000 RPM or more. On short seams, an operator would not be able to reach maximum speeds. Therefore, it is recommended to be used on small parts, while faster stitch types should be used for larger parts and longer seams. Some of the most common type of stitches in this class are stitch type 301 and stitch type 304. The 301 is referred to a plain stitch or a straight stitch. It is the stitch type performed by the standard home sewing machine. Equal amount of needle and bobbin threads are used, and upper and lower threads interlocks in the center of the fabric. The 301 stitch classes uses the least amount of thread and produces the flattest stitch. It is the tightest and the most secure stitch among all stitch types. Because this class stitch formation in the seam on the both sides of the seams, it is reversible and used extensively for top stitching, especially along collars, cuff stitches and front of the jackets. It is poor choice in areas that need to be stretched as it has least amount of elongation potential. The 301 is inappropriate to attach elastic or sew net or bias seams that are expected to stretch. Type 304 is the traditional zigzag stitch that is used to sew appliques, attach lace on lingeries and produce fagoting. Other types of zigzag lock stitch are class 308 and 315, which form a longer and a wider zigzag by using several stitches before changing direction. Fagoting is a decoration stitch used to connect two plies of fabric but allowing space between the pieces. It provides elongation and is smooth and will not be ravel out. The 400 class is the second most in fact frequently used stitch type. This multi-stitch chain stitch requires one or more needle thread that forms loop as they pass through the fabric and interloops with the looper thread on the underside. All of this feeds continuously from the cones. The 400 class stitch requires a upper and lower thread and uses a looper to carry the lower thread and form a thread loop on underside of the fabric. Machines producing 400 class stitch do not backtack, although stitches can be condensed to secure the ends of the thread. The most common stitch type in this stitch class is 401 or 2-thread chain stitch. Stitch type 402 or cording stitch, stitch type 404, stitch type 406 and 407. We will look at each of these in detail. The 401 or 2-thread chain stitch is also called double locked chain stitch. Its appearance is the same as the 101 stitch with a flat straight thread formation, similar to a lock stitch on the face of the fabric and a loop on the underside. The 401 stitch can be unravelled but only if the looper thread is pulled in the direction the stitches were formed. The 401 stitch machines are capable of operating at very high speeds. These chain stitch machines often use multiple needles to produce parallel rows of stitching. The loop formation of the chain stitch elongates when extended. Thus, it is used for seam that requires elasticity such as setting sleeves and attaching elasticity. This stitch type is also well suited to automated sewing equipments such as automatic seamers. Stitch type 402 or cording stitch is used primarily for stitching permanent creases. It uses two needle thread that produce two parallel rows of stitching on the face of the fabric. A loop thread travels between the two needle thread on the back of the fabric, creating a ridge or crease between the needle thread on the face. This type of the stitching can be formed on sportswear where a crease needs to be maintained and on the back of the gloves. Seam types 404 stitch is similar in appearance to the 304 seam in the sense that is also a zigzag stitch, except the difference that it is formed as a chain stitch and contains loop on one side. Stitch type 406 are known as bottom cover stitches. They are used to cover seams or unfinished edges on the inside of garments and to keep them flat. They appear as two or three rows of the parallel lock stitching on the face of the fabric while looper thread connects the rows on the back. The 406 stitches uses two needle thread and one looper thread like a 402 except that is does not rest up. Stitch type 406 is used to produce flat, comfortable seams on neckline of t-shirts, bottom filling of t-shirts, or on binding of men's briefs. Stitch type 407 is very much similar to 406 stitch, except that it uses three needles thread and have even more stitch. The primary use of 407 stitch is to attach elastic to undergarments, which requires maximum stretch. The stitch type in this class are formed with one or more group of the threads. These are characterized by loops from at least one group of threads passing around the edge of the material. The loops form a narrow band of stitching along the edge of the fabric with threads intersecting at the edge. This prevents the fabric from fraying. These stitches have high elasticity, do not unravel easily, and a trimming knife on the machine ensures a neat edge prior to sewing. They are often called overedge, overcast, overlock, surge or mirror. Overedge machines must have three stitch forming devices: a needle to carry the thread through the fabric, a looper or a spreader to carry the thread from the needle to the edge of material on the bottom, and a looper or spreader to carry thread up and over the edge of the material on the top. The various stitches type use various combination of these three devices. The odd numbered stitch type for 501, 503, 505 and 521 are known as break oven stitches because they act similarly to the spiral back of a notebook. The fabric is held tight together but not secure along the inner edge of the stitching. This allows the stitch to break open. These stitches are best used for edge finishes and hem. These stitches are characterized by loose thread on the bottom that is pulled to the edge of the fabric where it interloops the looper thread. This creates a pearl stitch or interlooping of thread that wraps and protects the edge of the fabric. The even numbered stitch type in this class 502, 504, 512 and 514 have a much tighter needle thread that allows the two layers of the fabric together at the actual seam line. These stitches do not green through or become exposed between the layers of the fabric. These stitches also have a much smoother appearance and are more durable. Serging is the process of finishing a single ply of the fabric to prevent raveling. This is often one of the first processes in sewing a garment, if another edge finish is not to be given later in the production. Type 503, 504, 505 stitches are overaged stitch type that are used for serging. Type 503 stitch is also formed by two threads, a needle and looper thread. It is used for blind hemming and serging. It is used mainly for hems in t-shirts and other kit garments, and serging seam of dress slacks because the two-thread construction is less likely to press through the garment. Stitch type 504 and 505 are three-thread overage stitches that are formed with one needle thread and two looper threads. They require more thread in the formation, but they also have more stitch. Type 504 is highly extensive and but it secures stitches that makes an excellent seam of knit garment, such as seams of cut and sewn sweaters. It is most common of 500 class. Stitch type 512 and 514 are sometimes called mock safety stitches. They are 4-thread overage stitches. They are formed with two needle thread and two looper threads. The type 514 stitch is stronger and more elastic than 512 stitch, but both may be used for seaming, knits and wovens. However, 514 stitch makes a wider seam and may be desirable for some knit garments. Stitch type 515, 516, 519 are combination of one overage stitch and a chain stitch. These types are called safety stitches because the chain stitch that closes the seam is backed by another row of tight overage stitches. Both rows of the stitches are formed at the same time. This type of the seaming is widely used by manufacturers of the shirts, jackets, blouses and jeans. The covered stitch or 600 class stitch, oft called as flat lock or a flat seam stitch, is an advanced version of 400 class stitch, is used primarily on knits and lingeries. Machines producing the 600 class stitch are extremely fast and efficient, operating at 9000 RPMs. The stitch is formed by two or more needle loops passing through the material, interlooping on the underside and interlocking on the upper side. A spreader or cover thread fingers carries the cover thread across the surface of the fabric between the needles. These stitches, referred to as top and bottom cover stitches, are commonly used to cover both sides of the seam with thread. Threads must be chained off and be crossed by another seam. This seam class uses a lot of thread but provides excellent top and bottom cover and flat seams. Stitches in this class are most complex and all and may have up to 9 threads in total, including 4 needle thread. Stitch type 602, 605 and 606. Cover stitch 602 is very strong and elastic stitch used extensively for manufacturers of knit garments to cover raw edge and prevent raveling. They may be used for attaching flat knit or ribbed knit collar. When the upper spreader thread is removed from these stitches, they become 406 class. Class 602 stitch is a 4-thread stitch with 2 needle thread, 1 looper thread and 1 top covering thread. Covered stitch 605 is also a very strong and elastic stitch used extensively by manufacturers of knit garments to cover raw edges and prevent raveling. They may be used for attaching flat knit and ribbed knit collar. When the upper spreader thread is removed from these stitches they become 407 type stitch. Class 605 stitch is similar to the 602 stitch but with 3 needle thread and 1 looper thread and 1 top covering thread. The flat seaming stitch 607 trims and seams simultaneously. It is used to produce the flat butted seam on infant panties, men's briefs and other knitted garments. It is a 9 thread stitch with 4 needle thread, 4 looper thread and 1 top covering thread. We can estimate the quantity of the thread which can be consumed in manufacturing a certain style of the garment, either by measuring the seam length shown in the each stitch type and calculating the total amount from published ratio of thread usage or by unpicking and unmeasuring the thread used in the sample garment. The latter is more accurate because it allows for fabric thickness and stitch density. The chart here gives the appropriate net thread consumption ratio of typical stitch shown in 1 or 2 plies of the fabric. Having seen the pre-production and production process, let us finally look at the post-production process. Garment washing is normally done before after stitching according to fashion trends and consumer demands. Buyers ask for garment washing. For washing, apparel buyers mention exactly what type of the washing they need for the order. For example, a buyer Tom Taylor asks for washes such as vintage wash, cloud wash, softener wash or acid wash. Each wash has a different type of the appearance on the fabric surface. Wash types mainly depends on the product types. For denim products, heavy enzyme is required, whereas for knitted tee light softener wash may be suitable. The prime objective of the washing garment is to remove starch from what applied during the fabric manufacturing, soften the garment hand feel and improve bulkiness, remove dirt, spots, oil stains that accumulate on the garment during the manufacturing process, remove chemical used during the printing and embroidery process, fulfill customer demand, ensure that clothes can be worn directly after purchasing, give a faded look on any other colors tinted look to the garment, stabilize garment shrinkage and dimensional instability. To give you an idea about this activity, a few important washes have been explained here. Vintage means old look. To get an old or used appearance, garments are washed inside a washing machine with enzymes. Fleece sweatshirts are washed with heavy enzymes. Cloud wash gives white patches on the garment surface, making it appear like clouds in the sky. To get a faded look on garment surface, white stones with enzymes are used during washing. During washing, the fabric comes in contact with stones and the rubbing effect causes color to fade. Stone wash is generally used for washing denim products. For acid wash, the base color of the fabric garment is removed by spraying acid on the specific area. In the finishing department, garments are nicely pressed and packed into poly bags. A finishing department has the following sub-processes: washing of garment. Some factories may have separate washing department also. Buttoning and buttonholing, trimming thread, checking of washed and unwashed garments, removing stains, ironing or pressing, final checking of garments after ironing, mending or repairing work, tagging, folding and packing. Garment manufacturing includes a number of the process from receiving order of to dispatch of the finished garments. A process flow chart helps to understand that how raw materials are moved from one process to another process until raw materials are transformed into the desired product, namely the garment. It is important to note that the process flow chart of garment manufacturing process very depends on manufacturing facility and product types. Some companies complete the whole process in a single plant, while others outsource production jobs and other auxiliary processes. Finishing is the last step of the garment production. All mistakes made during the process accrue and can become a huge problem at this stage. The quality department also has a huge potential to improve products and thus requires special attention. In almost every factory surveyed, it has been proven that the costs involved in the department are excessive. It is vital that the department is given importance, since there is a great potential to make financial saving. Some companies examine the garment as many as 5 times and the number of repairs is excessive. Further, finishing department are overstaffed in most of the factories studied. This is obviously driven by the fear of rejection of orders or reworks. Work content can be reduced by installing a proper work control system and a culture for quality production. Surveys has shown that layout and workflow in garment factory was generally poor and disorganized. Not one of the finishing departments have adequate systems of control. Rather, the emphasis is only directed to delivery and not productivity. This is understandable in the present circumstances, but must be rethought since it is excessively expensive. Studies have found that finishing times are excessive in almost every factory, with the average finishing time per garment varying from 11.2 minutes to 57.6 minutes. It is also been found that none of the finishing department use bundle systems for control, nor do any of them have any form of scientific performance measuring techniques. There are no monitor control except to record the number of repairs. Finally, this module gives an overview of the machines used in apparel manufacturing industry, the cutting, sewing and finishing machines. Many garments require notches to be cut into the edges of them to enable alignment during sewing with other garment parts. A specialized notching equipment provides greater accuracy because a guide lines up the notcher with the cut edge. This gives a consistent depth of notch at consistent right angle to the edge. Where reference marks are needed away from the edge of a garment part, such as for the position of pockets, darts and similar features, a hole is often drilled through all plies of fabric in the lay. The drill mounting includes a motor, a base plate with a hole of allow the drill to pass through and a spirit level of ensure that base is horizontal and the drill vertical. On many fabrics, the drill is used cold and the hole remains visible until the sewing operator comes to use it. On looser weave fabrics where the hole may close up, a hot drill is used which will slightly scorch and fuse the edges of the hole. The hypodermic drill may be used which leaves a small deposit of paint on each ply of the fabric. If it is important that no marks remain on the fabric, a long thread may be passed through the lay which is then cut with a pair of scissors between each ply, leaving a few centimeters visible on each garment panels. All drill holes must eventually be concealed by construction of the garment. A straight knife is used where the quantity of the fabrics and cutting do not justify purchase of a computer controlled cutter. The element of a straight knife consists of base plate, usually on roller for ease of movement, an upright or a standard carrying a straight vertical blade with varying edge characteristics and an electric motor above it or a handle for a cutter to direct the blade and a sharpening device. The base plate on its roller slides under the glazed paper which is spread below the bottom of the fabric in a lay. Normally, available blade height varies from 10 cm to 33 cm. Usually, available strokes vary from 2.5 cm to 4.5 cm. The greater the blade movement, the faster the blade cuts the fabric. This enables the operator to rapidly and easily increase production. The straight knife is a common meaning of cutting lathes in conventional cutting rooms because it is versatile, portable, cheaper than a band knife, more accurate on curves than a round knife, and relatively reliable and easy to maintain. Even if a band knife is used for a man cutting operation, a straight knife would be used to separate the lathe into sections for easier handling. A band knife comprises a series of 3 or more pulleys powered by an electric motor with a continuously rotating steel blade mounted on them. One edge of the blade is sharpened. The band knife passes through a slot in the cutting blade table in a fixed position, and the section of the lathe to be cut is moved past it. Band knives are used when a higher standard of accuracy is required than can be obtained with a straight knife. The pieces that are to be cut are first cut on block and then cut exactly on a band knife. The elements of round knife are a base plate above which is mounted on electric motor, a handle of the cutter to direct the blade, and a circular blade rotating so that the leading edge cuts downward into the fabric. Blade diameter varies from 6 cm to 20 cm. Round knives are not suitable for cutting curved lines in high lathes because blade does not strike all the plies simultaneously at the same point as a vertical point does. Therefore, a round knife is used only for straight knife or lower lathes of relatively few plies. This method provides the most accurate possible cutting and at high speeds. To keep the larger systems fully occupied, they are frequently used in a central cutting facility that supplies a number of separate sewing factories. A typical computer cutting system has a table with cutting surface consists of nylon bristles that support the fabric lace but are flexible enough to permit penetration and movement of the knife blade. It is supported only at top. The bristles also allows the passage of air through the table to create a vacuum, reducing the height of the table and holding it in place. The carrier supporting the cutting head has two synchronized servo motors which drive it on track on the edges of the table. The cutting head contains a knife automatic sharpener and a servo motor which rotates the knife to position it at a tangent to the line of cut on curves. A sheet of airtight polyethylene covers the top of the layer which assists the creation of vacuum and allows significant compression of the lathe. The control cabinet houses the computer and the electrical equipment required to drive the cutter, its carriage and the vacuum motor. The spreader spreads the lathe on a conventional cutting table equipped with air flotation. Paper is spread below the bottom ply so that the lathe can be moved on the cutting table without distortion and so that the bottom plies are supported during the cutting operation. This paper is perforated to enable the vacuum on cutting table to operate to compress the lathe. The cutting table does not need to be as long as lathe. Its bristle surface can consist of a conveyor which assists in transfer of the lathe in sections from the spreading table and the cut work onto the bundling tables. Die cutting involves pressing of a rigid blade through the layered fabric. The die, called a clicker in the shoe industry, is a knife in the shape of pattern periphery, includes notches. Freestanding dies generally fall into two categories. They can be strip still, manufactured by bending the strip to the shape required and welding the joint. These cannot be sharpened and must be replaced when worn. Alternatively, they can be heavier gauge forged dies which can be reached resharpened but which are 5 times the price of the strip steel. They provide a high standard of accuracy of cutting, but because of the cost of the die, they are only appropriate to situations where large quantity of the same pattern are to be cut. Die cutting also offers much faster cutting than knife cutting for the same depth of the cut. It is appropriate, more economic for small parts which have the higher periphery in relation to its area. There are 4 main types of industrial sewing machines. The differentiation between them is based on design of the arm and needle point and post. These 4 types are flat bed, cylindrical bed, post bed and off the arm. Flatbed machines are most common type, and these machines resemble traditional sewing machines in that the arm and the needle extend to the flat bed of the machine. Workers typically use this machine for sewing flat pieces of the fabric together. These machines features a narrow horizontal column as opposed to a flat base. This allows fabric to pass around the and under column. The diameter of the cylinder bed varies from 5 cm to 16 cm. Workers employ the cylinder bed machine for sewing cylindrical pieces such as cups, but it is also useful for bulky items such as saddles and shoes. These machines features bobbins, feed dogs and or loops in a vertical column that rises above the flat bed of machine. The height of this column ranges from 10 cm to 45 cm. The post bed machines is used in applications that make access to the sewing area difficult, such as attaching imbel, making boots and gloves. The main type of feed mechanisms are drop feed, needle feed, walking feed, puller feed and manual feed. In drop feed mechanism, the drop mechanism lies below the machine's sewing surface. That is probably the most common feed type. In needle feed mechanism, the needle itself acts as feed mechanism, which minimizes slippage and allows workers to sew multiple layers of fabric. In walking foot mechanism, the immobile pressure foot is replaced with a foot that moves with the feet. This allows easier performance on thick, spongy and cushioned material. In puller feed mechanism, the machine grips and pulls straight seamed material as it is sewn. It can perform on large heavy duty items such as canvas tents. In the manual feed mechanism, the feed is controlled entirely by the operator who can do dedicated personal work such as shoes repair, embroidery and quilting. On industrial sewing machine, it is sometimes necessary to remove the feed dogs to obtain a manual feed. The application of an industrial sewing machine is also an important factor of consideration. For example, some machines come with an automatic pocket setter, which others include pattern programmability or electronic eyelet buttonholers. Furthermore, the strength and the design of the machine needs to complement the type of material you will be using. Industrial sewing machines are used for different purposes. Higher quality machines will be necessary for medium to heavy materials such as denim. Base level industrial machines may be adequate for lighter materials such as cotton. A particular machine's stitch type should also be noted prior to making a purchase. There are several dozen distinct type of stitches, each requiring between 1 or 7 threads. Plain stitches are most common used stitches in industrial sewing and include lock, chain, overlock and cover stitches. Yet another important features to look into is the size and speed of industrial sewing machine. Expensive machines will be able to sew more stitches per minute. Large machines provide a larger clearance area under the foot and bigger bed size. You will need to ensure that the size and speed of the machine you ultimately purchase will adequate meet your needs and expectations. Much like any industry, technological advances, globalization and changing business practices are affecting the apparel industry, shifting the emphasis on quick decision making through tools such as real-time data monitoring of the manufacturing floor. Traditionally, bundle cards were used in progressive bundle unit systems to track movement of bundles in the line and the integration of the barcodes in bundle tags facilities. Tracking of components and finished pieces in sewing lines. The overhead material handling system in unit production system made significant progress in integrating the barcode scanner or RFID scanner to monitor the process of each hanger, that is, tracking the each piece thereof. While brands like Eton, INA, Smart, MRT popularized the adoption of overhead material handling system, global mechanization of material handling in PBU system still lags behind. To facilitate workers to do their jobs efficiently, a number of ready-made and customized work aids and equipments are being used in the garment industry. Work aids are especially designed for activities such as material handling and folding. We will now review some of the basic work aids that are used in the shirt making factories such as raw material warehousing, cutting department, sewing floor and finishing department. Raw material warehousing uses the fabric trolley and a fabric roll forklift. The cutting department uses fabric roll strand, both movable and fixed, layer weight, cloth clamps, baker's trolley, waste disposable trolley and bins. The sewing department uses the disposable basket, sewing machine table extension, hunchback, single sloping table, profile for collar and cuff run stitch, as well as various types of the attachments, folders, hammers and guides. The finishing department uses a wire mesh WIP trolley, jet stand, bins, hanger stand, hanger trolley and carton transfer trolley. You have come to end of this unit. To summarize of this unit, you will receive an overview of various departments in the garment industry and been introduced to cutting, sewing and finishing process. You have also been given an overview of various equipment including cutting, sewing and finishing machines. Thank you very much.